Hello explorers and welcome to another video. Today we're going to tackle day 18 of Advent of Code. So let's jump right into it. And you see that I'm a little bit late here. It's already 3 hours in, but it's a Saturday. So let's take it easy and do some fun puzzle. So let's read here. Snailfish. You descend the ocean trench and encounter some snailfish. They say they saw the sleigh keys. They even tell you which direction the keys went if you help one of the smaller snailfish with his math homework. Snailfish numbers aren't like regular numbers. Instead, every snailfish number is a pair, the ordered list of two elements. Each element of the pair can either be a regular number or another pair. Pairs are written XY and XY are elements within a pair. Here are some examples of snailfish number per line. So I have a bunch of numbers here. This snailfish homework is about addition. Add snailfish numbers, form a pair from left to right parameters of the addition operator. For example, 1, 2 plus 3, 4, 5 becomes, and we just create a new pair of them. There's only one problem. Snailfish numbers must always be reduced, and the process of adding two snailfish numbers can result in snailfish numbers that needs to be reduced. To reduce a snailfish number, you first must repeatedly do the first action in this list that applies to the snailfish number. If a pair is nested inside of 4 pairs, the leftmost such pair explodes. If a regular number is 10 or greater, the leftmost regular number splits. So if a pair is nested inside of 4 pairs, the leftmost such pair explodes. If a pair is nested inside of 4 pairs. Once no action in the above list applies, the snailfish number is reduced. During the reduction, at most one action applies, after which the process returns to the top of the list of the actions. For example, if a split produces a pair that meets explode criteria, that pair explodes before the other splits occur. Okay. To explode a pair, the pair left value is added to the first regular number to the left of the exploding pair, if any, and the pair to the right value is added to the first regular number to the right of the exploding pair, if any. Exploding pairs will always consist of 2 regular numbers, then the entire exploding pair is replaced with a regular number of 0. Okay. Here is some example of the explode action. So in this case, we couldn't replace anything to the left, so there becomes a 0, and then the other part is 1 plus 8, so 9. The 9 is no regular number to its left, so it's not added to any regular number. And here we have another one where the 4 and 3 becomes 7 and then 0. 2 has no regular number, so to its right is not added to any regular number. And then this one, we add the 3 down here, we got 0 up there. And then this one, 7 and 3, yes, becomes 8, 0 and 9 over on the other pair. The pair is unaffected because the pair 3, 3, 2 is unaffected because the pair 7, 3 is further to the left than 3, 2. Okay. Explodes on the next action. It becomes okay. To split a regular number, replace it with a pair. The left element to the pair should be a regular number divided by the 2 rounded down, while the right number elements of the pair should be a regular number divided up. For example, 10 becomes 5, 5, 11 becomes 5, 6, 12 becomes 6, 6, and so on. Here's the process of finding the reduced results of these two. So we add 1, 1, so we have this, and then 4, 3 will become something that needs to explode. So that becomes 7, 0. And then we have 8, 4 that needs to explode as well. So we get 15, 13. And then 15 needs to be split. And then 13 needs to be split. And then this needs to explode again. Okay. So that makes sense. You work from the left to the right. Once no reduce actions apply, the snailfish number that remains is the actual result of the addition operation. Yes. The homework assignment involves adding up lists of snailfish numbers, your puzzle input. The snailfish numbers are each listed on a separate line. Add the first snailfish number and the second, and then add the result and to the third, and so on. So we have these additions, and this one exploded, and here we have another one that has exploded. And then we have some slightly larger example where you have all the actions. To check whether it's the right answer, the snailfish teacher only checks the magnitude of the final sum. The magnitude of a pair is 3 times the magnitude of the left element plus 2 times the magnitude of the right element. The magnitude of a regular number is just that number. For example, the magnitude of 9, 1 is 3 times 9 plus 2 times 1, which is 29. The magnitude of 9, 1 is 21. So these two would become 129. And then we have a bunch of these where we get different numbers. And then we have this homework assignment, which sums up to 4,140. So my thought here would be to create a class that is a pair that could either have numbers or pairs as their children, and then create functions for exploding and creating functions for splitting, and also a function to calculate the current depth of this, or set the current depth of the pair. An addition should only be creating a new pair and putting those two pairs together. So that would be, I think, the easiest of these operations. But let's see. I will do this and then get back to you what I actually came up with. And we are back. So let's see here, let's jump into this, and we have this little bit more advanced example, and when you run that you get this output and the final magnitude sum of 4140. And if we look at my code here, I have 4140, and I have that specific string here that we saw earlier here. So I've verified that the test works now. So let's look at what I did here. So first off, I have math pair, and this is a pair of 2 of these. And I can create a math pair by just giving them a string. So I go through the list of tests here, line by line, and if I have the first one, so I haven't done no math pair before, I will just add that string. And if not, then I will take the first string that I had and just create a new math pair with the next string. So that's an addition, pretty much. And then when I've done that, I will set the depth for everything. And then I will go through here, and while the max depth that is over the whole structure is larger than 4, so I have something that will explode, or if the max number anywhere is over 9, which means that it needs to be split, then I will first go through and explode everything and set the new depth, and then I will split and set the new depth, because depths will change while I split and explode. So that's pretty much it, and then I print out the current math pair, which could have a lot of pairs in it, and also the magnitude. So that is a very small function. The large thing is the math pair, of course. So here we need a little bit more space. It's a lot of code, as you see. It took me 4 hours to do this. So we have first left and right, which is just objects, so they can either be integers or this math pair. I have a depth, so I know where I was. And I also know if I have visited this. And this is important if you are up in a structure and exploding and then going back down. You don't want to go up and manipulate something that you have already been visiting. And then I will go here and set the string to beginning and end length. And if it starts with any of these parentheses or square brackets, I will increase the beginning and decrease the end in order to remove the first layer. And then I will create the split terms. So I will have the terms that is in this specific layer. And the split terms, only thing that does is goes through the string and figures out where to put in a pipe, and pipe will be the actual thing that we will split on later on. So if we don't have any nesting, then we will just replace the first comma with a pipe. Otherwise, we will figure out where the pipe should be and then have a substring on each end of that. So that's pretty much what I do to split the terms, and then I will create a math pair with the right hand side, and if it doesn't have any commas in it, then it will just be an integer, and I will put the right side in there, and same goes for the left side. So that's how I create the pairs, and I can also have a pair that I put into a larger pair. So now I've gone through those. Set depth is not an advanced function either. I go through and increase the depth as I go down in the tree and just add the depth value to each pair, and then also reset the visited flag. So I can do another iteration. Explode. It first checks if this is a math pair, the left or the right. Then it will explode that, and beginning with the left side, of course, and then the right side. And if not, it will go down here and see, are we on a deeper level than 4? And both of these are integers, then this is the one that we want to explode. So we will just return this. And this will mean that this MP will be set. And when you come down here and it's not null, then we need to do some things here. So first off, we will see if the left-hand side is this object. And if this object, this MP object, is the left-hand side, then we start to operate on that. So first we set the left-hand side to 0. So we will remove that side. And then we will say that we have visited this one. And if the right-hand side is a math pair, then we will go, and it's not visited yet. We will visit it. Or if it has been visited, then this has also been visited. Okay. That's interesting. Yeah. So, because we set visited up here already. Yeah. And then if not, we will return the right-hand side set right. So here we will take the value of the MP right-hand side and set on the right-hand side. So we go down the right-hand structure and set this MP value. Otherwise, if it's not a math pair, then we know that this is the one that we will add to. So we will add the MP, the math pair that we have taken that we want to explode. We'll add that value to the right-hand side's value. And then we will set the MP value, this math pair that we're exploding, to -1. So we know that we're done with this one. And then we will return that. If the right-hand side, on the other hand, is this MP, this thing that we want to explode, we do the opposite thing and we set the left-hand side of that right-hand side. So we will set the left of the right-hand side. And then the same goes here. We set the left value of the right-hand side and remove that we have used that value. And if none of them are this specific value, we need to check if we are done with this math pair that we want to explode. So if the left-hand side is not 0, then we will go in and handle that. If the left-hand side of the current object is a math pair, we need to handle that exactly as we did above. And otherwise we'll set the left-hand side down here to the addition. And the same goes for the right-hand side. So that's a lot of things that we need to do. And every time we return this math pair, so we know further down in the structure if we have already handled any of these sides. So the explode function was a lot of trial and error and trying to figure out how that should be. And when we have come to a path where we want to explode upwards in the structure again, then we have these set left and set right. And if we set left, then we are setting on the right hand side, but we're setting the left value, which means that we will go up the right hand side, figure out if the value is still a math pair, then we will continue up that branch and we will set the left MP value to the right hand side as soon as we haven't a math pair there, and then we say that we have handled this value and return it. The same goes for the right hand side. So those are just mirrored, those functions. Then we have this split function, and I had before has split, so I could do multiple splits, but I've changed it now so it's only doing one split before it tries to explode again. So here we check if the left hand side is a math pair, then we will run split on that as well, and if we have done any splits there, we will return true. Else, if it's not a math pair, we will take the integer value of the left hand side and check if it's larger than 9. If so, create a new math pair, and we will take the floor div of one of them, so we get the lowest value, and then we will remove the floor div of this division by 2 from the other one, so we will get the larger value on the right hand side, and then we will set our left value to this splitted pair and return true. And we do the same thing for the right hand side. So split, pretty simple operation. We can set values on the right hand side and the left hand side. I'm not sure if we ever do that. Yeah, we do that in this floor div thing in the split here. So we could actually just use set this value for that, but we are using the function. And I also have this toString, and that's mostly for debugging purposes. Here I can also see if this depth is something that I need to explode. So I set a little star there, so I know that this is a value I need to explode later on. And then I will show the right hand side and the left hand side, and then this exploding depth here. Calculating the magnitude, as you might expect, I set a big integer to 0, and then I will get the magnitude for the left hand side and multiply that by 3. And if it's not a math pair, I will just get the integer value and multiply that with 3. Same goes for the right hand side, and I add everything up and I return that value. The max depth it sets the current depth, and then it goes down the left-hand side and figure out if any of the depths on that side is larger. And same goes for the right-hand side, and then returning that depth that is the largest. Maximum number does the same thing here, and it goes down the left-hand side and sees if the number available here is the largest, and then it will return back and see if what is the current largest number. And if that is larger than 9, we will continue. So now we have gone through that. Let's try to run the real data, because I have a bunch of those strings here as well, and see if that will give us a good result. It might take a while to run. It gave us 4202, which is not a super large value, so let's try that, see if that's the correct one. Yes, you get a gold star, I get a gold star, everybody gets a gold star. Nice. So let's see what part 2 entails. You notice that a second question on the back of the homework assignment, what is the largest magnitude you can get if from adding only 2 of the snailfish numbers? Note that the snailfish addition is not commutative, that is x plus y is not same as y plus x. That can produce different results. Again, considering the last homework assignments above, this one, the largest magnitude is 3993 if you are adding those two together. What is the largest magnitude of any sum of the different snailfish numbers from the homework assignment? Okay, this should not be that hard to figure out either, because the largest one here, there was that one plus that one, okay? So we need to add every line to every other line and trying to figure out which is the largest one. And we can't add the same line. That's the important part as well. So I think that we need to now have a list of lines, pretty much. And we also need to have them added in the opposite direction. So not only adding in one direction, we need to add in both directions. So let's go back to test here. And we need to figure out how to add everyone with each other and the other way around as well. So I think that we can create a function to figure this one out. I think we will do a day 18b here. Create class day 18b, pretty much, and main like that. And I will copy all the data up here. That could be good to have. And let's see here. For string s in test, split on that. And then we will have a list, string, array, or list, new array list, and list, add string. So now we have a bunch of strings in this list, and for integer I 0 to integer list size I plus plus. So here we want to do something, and we also want to have largest magnitude, and that's 0 at the moment. And then we will do size -1 like that. And we will we will have another one here that we call J, like that. And we will do list get I, math pair, mp1 equals to math pair, new math pair, like that. And this is number 2. So now we pretty much want if I is equal to j, then continue, because those we don't want to test. We are able to test everyone else, but not the same ones. And let's see here. What did they say? They said, okay, so we want probably to keep the largest ones, just to math pair large 1 null large 2. So if mp1 and we want to do this function that we had earlier here for calculating them together, like that. So math pair mp is equal to math pair mp1 mp2. So that's what we want to calculate. We want to run this, and mp magnitude, if that is larger than the largest magnitude, then large 1 is equal to mp1, large 2 is equal to mp2, largest magnitude. Okay. And we figured out that these magnitudes weren't that large. Or do we want, we can still do big integer here. Big integer 0. So, and then we have magnitude, the largest magnitude compared to this magnitude is larger than 0 or less than 0, then largest magnitude is equal to mp get magnitude. And then down here we will print line largest 1, largest 2, and largest magnitude. So let's see if this will give us the same result that they had in the other, in their example here. We get a bunch of outputs. Do I put it? I put it in this one. So let's do that. So we get one largest magnitude of 8,000. So that's not correct, right? I ran the test. Yeah, ran the test. And we are back! And this problem should not have been as hard as it was. It took a while to debug. It's a little bit strange with these numbers and so on. We're looking for the number 3993, and we actually got the number 399993. And that reason that I didn't get it the first time was that I forgot to set the depth before I started the process, which gave me a totally different number, which was strange. So let's go over to the data here and let's run that. And we will get another number, so 4779. If we go over to here and put that in, yes, you get a gold star, I get a gold star, everybody gets a gold star. So that was the right number. So what we did here, pretty simply, we checked all numbers with all the other numbers, which means that we took 2 for loops that went through the list, the full size of the list. If it was the same number, we didn't add them together, but we add all the other numbers together. We pick the I and J numbers, number MP1, MP2. We create a math pair of those. We set the depth. We go through this while loop that we had in the other program where we actually did all the reducing and so on, back and forth, and explode, reduce. And after everything has been done with this math pair, it's done, ready. We take the largest magnitude, compare that to the magnitude of this specific number. We start with a magnitude of 0 up here. So we compare it. If this new magnitude is larger than the largest magnitude, we put it in to the largest magnitude and then we write it out down here. So not much to this, but it's much cleaner to do it in a separate program like this so we can look at it because it was a little bit different than the first example that we had. I hope that you found this interesting. I hope that you learned something today. This was a lot of work to get this rolling, but I really like these things that you need to create a class, you need to think about how to traverse the different paths and so on. So it was a lot of fun, a lot of debugging, a lot of figuring things out. It took me 5 hours to do this one. So I really like this one. If you like it, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you solve this in a different way, leave a comment in the comment section down below. Or if you have any other comments or suggestions, leave them down there as well. And I really hope to see you in the next video.